So we're going to start with this first lesson here with isosceles and equilateral triangles. Okay, so remind me, those of you who actually studied your implied statements that we got, what does an isosceles triangle imply? Yes?
Two congruent.
Oh, so close and yet so far. Yes, Colin?
A triangle with two or more congruent.
That's not how it was worded. Y'all got to learn your implied statements. Ibrahim?
A triangle with at least two sides.
With at least what? Two congruent sides. You get the candy. You guys, being close to the implied statement or something that means the same thing is not acceptable. You need to know the implied statement. Okay? So I've got my implied statement. Oh, look! Behold, yon isosceles triangle. Does it have two congruent sides? There they are! Well, guess what? If you have two congruent sides in a triangle, they get named.
Let's go. Let's go.
Yeah. And to help you figure out what the name is, I'm going to draw a little picture.
Right now?
What the heck is that?
Oh! What body part are the two congruent sides of the triangle? They're the legs!
Yeah.
You are so impressed. See? The congruent sides of isosceles are called the legs. Mm-hmm. And the legs are going to be on the ground. What should we call the ground of the triangle?
Base.
That's the base. Ooh! So what should we call the angles where the legs meet the base? No, because the foot could be sticking up. So what should the base angle is this interior angle.
Remote.
Ankle.
That you would think it would be great to call it the ankle angle. That would be great. But sadly, it doesn't. Now, you can headcanon that and decide that they could be called the ankle angles. But no, they're just called the base angles.
Are you serious?
I know, it's so boring. But you can have the headcanon if you want. I do not stop you.
Go.
Okay. And then up here where the legs meet, what do we call that angle?
The point.
We're going to call that the vertex angle to keep things appropriate. So that's the vertex angle. Because calling it the crotch angle just doesn't fly. So we're just going to call that the vertex angle. Now, the thing about the vertex angle, it's the included angle between the legs of an isosceles triangle. Isosceles triangle, okay? An included angle is just an angle that's between the two sides. So this one right here, the vertex angle is between the two legs where they touch each other. These base angles down here are not included between the legs. They're hanging out down by the ankles. Okay? So now that you know all the body parts of your isosceles triangle, now I'm going to just use those words like crazy to do, the base angle theorem. Guess what's involved in the base angle theorem? Shockingly, the base angles. But what we're going to do first is I'm going to start with an isosceles triangle. And how many sides have I marked congruent? Two. So in a triangle, if you have those two congruent sides, guess what it implies? Look in the picture. What do you notice?
Two
congruent angles. And those angles are the ones that are opposite the congruent sides. Did you notice that? If I go opposite the congruent side, I get to this angle. If I go opposite this side, I get that angle. So the opposite angles are congruent. Now y'all remember back to the dark ages of, Unit 2, and we did logic, and you remember how to make a converse.
Yep.
So candy to someone who can tell me the converse of this theorem. The picture helps you. Okay? Oh, you, Elliot?
In a triangle, two congruent angles
Two congruent angles.
implies
Mm-hmm.
two congruent sides.
So close.
Opposite
Opposite
sides are congruent.
sides are congruent. So if these angles are congruent here, you can go across to the other side and make the sides be matching up. So if the angles match, the sides match. Done and dusted. What if the angles aren't the same size?
Then they aren't.
Then the sides will not be the same length. And we talked about that a little last time, where we said if you had 3 different angles in a triangle, you could tell it would be scalene. Because if any of it had been congruent, you would have had congruent sides. That comes from that theorem, the base angle theorem. You're like, oh, well that's not so bad. But then, because we're mathematicians, we're like, well, what can I learn from that? I can create a corollary. Corollary is just the thing you get from it. And so check this out. See how I have 2 congruent sides up here? What will be true? The opposite angles will be congruent, right?
Yeah.
But wait, could I turn my picture? So now, what about look, I have 2 congruent sides here. What will be true about the angles opposite them? They're also going to be congruent. But wait, there's more. What if I just look at these 2 sides? They're congruent. So what has to be true? Their opposite angles have to be congruent. And so, oh look, everything ends up being congruent. Wait, this sounds awfully familiar. This is just an equilateral triangle. And what does it imply? What did we call this?
Equilateral. Equal angle.
Equiangular.
Equiangular.
Not equal angular, equiangular. So you can either put A for angular or an angle, but there's no L in it. The L in here is from the word lateral. That should, well, hold on, that should be triangle, not angle. That should be triangle. Forgive me. Equiangular triangle. There you go. I can write, but it's been a long day.
Yeah.
Okay? Wait, I told you that last time. If the 3 sides were congruent, all the angles were congruent? Okay, KV2, whoever can tell me the converse of the corollary of the base angle theorem. What do you think, Camila? Here's the picture, helps you.
An equiangular triangle
Okay, equiangular triangle,
implies an equilateral.
an equilateral triangle. Oh, look! The original and the converse are both true. What does that tell me? It's biconditional. And when I go to look in here, let's see, equiangular is a triangle with 3 congruent angles, and equilateral implies, it shows it is biconditional here. Equilateral implies equiangular is biconditional. It's separated here, but in here it's doubled up. The weird thing is that these 2 guys are also converses, and they're both true. But for some reason they're kept separate, the base angle theorem and the converse, instead of have it being written biconditional. How come? I don't know. Maybe because you have to change the wording slightly when you converse it? I don't know. But anyway, we're moving along. Look how many things we've done already. We've already done 56 implied statements this year. That's a lot of implied statements. Look at all those chickens. yourselves, answer this question. Is it possible for an equilateral triangle to have an angle measure other than 60 degrees? If yes, why? If not, why not?
No.
Also, these triangles always.
Never mind. It's a trick question.
Yeah.
Daddy, no. Mom wants that.
Yes.
Mom is gonna take me.
We're not over here on that example yet.
Oh, find the measure. Oh.
Okay, so what does equilateral imply? Equiangular. Okay, well if that means I have all equal angles, how many degrees are in our triangles? So I have to take that 180 and divide it evenly amongst 3 angles. That's always going to be 60. So when you have an equilateral triangle, would you ever have anything other than 60?
No, ma'am.
No! You literally cannot have anything other than 60 in an equilateral. If you're not equilateral, all bets are off. If you're in non-Euclidean geometry, all bets are off. But since we are sticking with the parallel postulate, and we're sticking with 180 degrees in a triangle, it works. Knowing that, find x and y. No, that's not an exponent 0. That's supposed to be degree symbol. Ooh, we got one done. Ooh, let's see.
I think I'm ready.
I'm finished.
How does this work? This is a 90-degree angle.
If you end up having this right, you get candy because you were the first.
Oh,
Okay. So, notice, what's something you see in the triangle, in the picture? This is equilateral, which implies equiangular. And what are the angles in an equilateral, equiangular triangle going to be? 60. Well, you just found x. Okay, that was rough. Then what did you have to notice? That there's a right angle here. How big are right angles?
90.
90? Well, if it's 90, how big is this little part right here?
30.
It's 30. And then you notice something else. Wait a minute, what kind of triangle is this guy? Isosceles. It's got 2 congruent sides. If 2 sides are congruent, then the opposite angles are congruent. So how big is this angle up here?
30.
Also 30. So I have 30 and 30. How big does this guy have to be?
120.
Has to be 120 degrees.
Wait.
Did you notice how many properties along the way I had to point out?
Oh, yeah.
Okay? And there were so many of them. And so you have to, all of these are in your toolbox of stuff that you have to figure your way through these problems. You have all the information you need, you just have to hunt it down. Okay? So, let's try one. Let's try one. And you know what, that's too simple. Try this guy. Try to find the measure of angle R. You have all the information you need in the picture. Oh, look at that. Wow. So this angle must equal this angle right there, because they're congruent angles for opposite congruent sides. And so this guy must also equal 2x plus 2.
That's literally
all the time if you would say the numbers. No, it's okay.
And then, since I know that a triangle has to sum to 180 degrees, I can add all three of those to get 180 and solve the equation to find x. So let's see now how the students in the class have done with that. Okay, y'all, so please notice that when I was looking at this, I immediately noticed that I had two congruent sides. So I went and marked the opposite angles being congruent. Did y'all catch that? And then since this bottom one was 2x plus 2, that meant the top one had to be 2x plus 2. And now I have all three angles of the triangle, which all have to add up to 180. So I'm sure you did 2x plus 2 plus 2x plus 2 plus 3x plus 1 equaling 180. And you would have mathed until you got x equaling
25.
25?
Yep.
And if you left it there and you were done, you'd be wrong because that's not what it said to do. That's just part way. How am I going to find angle R?
Plug it in.
Plug it in, substitution property. So 3 times 25 is 71 plus 1? 76 degrees. Yeah, 75 plus 1. Get the candy because I can't think right. And since I was finding the measure of the angle, of course you're not going to leave it naked. You're going to put the degrees on it so you don't get half your points taken off. Like some people did on the test, which was awkward. Okay? Questions on this one? Cool.
Isn't it vital?
Alright, so when you go to the next page, oh, guys, these are basically the same thing. We don't need to keep doing that over and over again. So instead, let's see how bad I can confuse you. Try number 6. We'll see how many people fall for my trap.
There's no 180.
Ceci didn't fall for it.
I think I know.
So when you look at this one, you'll notice that since you see 3 congruent angles, you know that it has to have 3 congruent sides. Which means that this is congruent to that, and they are equal. So you can do 5x minus 12 equals 3x minus 4.
I did that.
You did it?
Yeah.
You did the same thing as me? Yeah, I saw that it was equiangular.
So they're the same.
So I said that all the sides have to be equal as well, because it's equilateral, which means that these two sides must be congruent, and so I can set them equal to each other over here. And then I'm sure you're going to do a bunch of math or something to figure out how much x equaled. What does x turn out to equal?
4.
It turns out to equal 4. And so how do you find DE? Subtract them from 180? Oh, wait, what equation?
It's equal to the other.
Yeah. Notice, are we finding angles?
No.
So am I going to use 180?
No.
But that's a trap a lot of people fall into here. Is they think, oh, triangles have 180 degrees. Yeah, degrees go with angles, not sides. So instead you plug this in. 4 times 3 is 12 minus 4 is 8. 4 times 5 is 20 minus 12 is 8. And so how long is this side?
8.
It's also 8.
That was not cool about that.
Questions, problems, complaints, concerns, or comments here? Okay, we're going to skip that one because it's more of the same. And we're going to go to number 7. Set up number 7. What's the best thing you can do to set it up? Draw a pretty picture. And they tell you it's isosceles. Yep. So it's talking about my base angles. Do you know how big your base angles are? It didn't tell you, did it? So what letter shall we pick for them? Okay, X works. And then it tells you, ooh, the measure of my vertex angle is 12 more than 5 times the base angle. Yeah. How am I going to find it, though? I don't know the vertex angle.
You put them all up with a 180.
Oh, if this is my vertex angle, and these are my other two, that's all 3 angles of the triangle. What do the angles of a triangle add up to? So I can take this 12 plus 5x here, add the 2x angles from the bottom, whatever they are, and know that it has to sum to 180 degrees. I know, it's thrilling. So 8x plus 12 equals 180. Was it 8 or 7? 7. Okay. And when you work that out, what does x come out to be?
24.
24, thank you very much. Oh wait, if I plug that in, how big are my base angles?
24.
24 degrees. Nice, problem solved.
No.
Oh, I wasn't supposed to find the base angles?
Some of them.
Some.
Oh,
48.
I have to find the sum of the base angles, which is 48 degrees. Be careful as you work the problems that you don't just find what you assume they're going to tell you to do, but that you actually read it. When all else fails, read the instructions. Okay? And then take a moment and argue amongst yourselves. Figure out these 5 true false.
At most.
True.
It's gotta be true.
Will you be here on Tuesday next week?
Will I be here what?
Tuesday next week, because you can
No, I'll be here. Yeah. It's still going to be a Tuesday, so I don't have to do my morning meeting. That's why I can't be here on Monday. All right, let's argue about it a little. Okay. A, all isosceles triangles have at least 2 acute angles. True. In fact, every triangle has at least 2 angles that are acute. It's that third one that throws you off. Okay? It's number B. If the perimeter of an equilateral triangle is P, the length of the sides is P divided by 3. True or false?
True.
Also true. They've got to be the same size, and so you have to divide evenly by 3. All isosceles triangles are equilaterals. That's a false. What about the converse? Are all equilateral triangles isosceles?
True.
That one's true. So remember, converse and original do not always have to have the same truth value. Okay? D, if you know the length of one of the legs of an isosceles, can you determine its perimeter?
False.
You can't.
But you know 2 of the sides are congruent. So,
But you don't.
but you don't know the third side.
No, ma'am.
So that's not good enough. When can you get the whole perimeter with just one side?
The vertex or the base?
If it's equilateral. If it's equilateral, you can do it. Or if you know trigonometry, but y'all don't know trigonometry yet. Okay? And then if the exterior angle of an equilateral triangle is obtuse.
Certainly. Yeah, false.
I'm hearing true and false. Well, let's draw the picture. I've got an equilateral triangle, so how big are all its angles?
60.
But those are interior angles. How big will the exterior angle be? 120. So the exterior angle is obtuse. Awesome.
6 and 7 degrees.
I'm gonna go on the, splendid.
Wanna go, boys?